We will, but first we have to think about. So isolate the absolute value, done. All we have is the absolute value over here. Now, all of this stuff could equal positive 14 and it be true, or all of this stuff could equal negative 14 and it would be true. Because the absolute value of positive or negative 14 is 14. So we can take all of this stuff and set it equal to the positive, and all of that stuff and set it equal to the negative, and both of these give us the ability to get the correct answers. Now we solve. So once we split it up into the two possible equations, then we solve. So we get x equals 20, or this gives us negative 8. All right. Yes, sir. If there was stuff outside of the absolute value, yes, you would need to move it. Let's test to make sure that what we just did makes sense. If we take and plug in a 20, is the absolute value of 20 minus 6, does that equal 14? Yeah. Let's test the second one. Does the absolute value of negative 8 minus 6, does that equal 14? Yes. Okay? So you can check your work. You don't have to. For the sake of time, you may not even want to. But you can kind of just plug it in your head. Does my answer make sense?
So the only time you take out like numbers that are the absolute values when it's outside?
Correct. Yeah. The only time we would move stuff first is if we had numbers outside of the absolute value. Okay, so the second one, actually let's make this a you try. I think you can do this. You try number 3. Okay, so since it's already isolated, we take the absolute value and set it equal to the positive and the absolute value and set it equal to the negative and solve. So that on each case, we're just going to subtract 1. So we get 7 or negative 9. So if we plug in 7, 7 plus 1 is 8. That works. If we plug in 9, 9 plus 1, negative 9 plus 1, there we go, equals negative 8. But the absolute value of negative 8 is 8. So that one works. Okay. Even though these look a little different, still works the same. So we set this equal to the positive, and we set it equal to the negative. So there's a few more steps in solving these. These are 2-step equations instead of 1. So we have to move the 3 now, and then divide by 2. So we get x equals 9, or
X equals 12 minus.
okay. So this does give us the negative 12, and then when we divide by 2, we get negative 6. All right, so does that make sense when you just have the absolute value? All right, there's something wrong with number 5, very wrong. I set up a problem where it has an absolute value equal to a negative number. Is that possible? No. An absolute value cannot be negative. So there is no solution, and there is no need to work that problem at all.
I thought even if it was negative, like it would still have a positive negative.
Well, it does. This part would have a positive and negative to it, but when I take the absolute value of it, can I make it negative?
Oh,
No.
No. So, anytime we have an absolute value equal, that doesn't look like absolute value. Absolute value equal to a negative number, then there is no solution. Okay, this time it's an absolute value equal to a positive number. So we can do it. So we split it up. Even though x is negative, we can still do it. So we split it up into 5 minus 2x equals 9, and 5 minus 2x equals negative 9. And we solve these. So we subtract the 5. Now we've got a negative, but that's all right. And then we divide by a negative. And we get a negative as our answer, which is okay. We've gotten a negative there, and a negative there, and a negative there. Negative answers were okay. But let's test and see if it works. What is negative 2 times a negative 2? It's a positive 4. What is 4 plus 5? 9. It works. All right, now let's try this other one. So when we solve this one, we get negative 14 here, and when we divide by the 2, negative 2, we get a positive 7. So this time when we plug it in, we get 5 minus 14. And 5 minus 14 is negative 9. But what is the absolute value of negative 9? 9. Okay? So for each one of these, the absolute value part was already by itself. So we didn't have to do step 1 at the top. We do it at the bottom. So let's go look at those types of problems. Now, this is kind of important. You cannot distribute into an absolute value. Can't do it. We have to isolate the absolute value. So there's a 3 right here. We cannot distribute into it. We have to get rid of the 3. So step 1, divide. Because right now it's 3 times an absolute value. So we're going to have to divide. Now the 3's are going to cancel. And I'm left with the absolute value of 2x minus 2 is now equal to 6. So our goal to get the absolute value by itself, our step 1, isolate the absolute value part, has been accomplished. Now it works just like the first 6 we did. Okay, so let me see you do it. So here we get 2x minus 2 equals 6, and 2x minus 2 equals negative 6. So when we add 2, here I get 2x equals 8, so x is 4. Or here when I add 2, I get negative 4. So when I divide by 2, I get negative 2. Make sense? Alright, so on this one, what would be my first step? Divide by 4. Divide this side by 4, divide this side by 4, and we get this. Absolute value of 5x minus 1 equals 9. Okay? Now this one, we're not going to solve this one. This one we are going to solve, but we got extra to get rid of first. We have to isolate the absolute value. So, I got a 2 to get rid of and a negative 1 to get rid of. If I gave you this equation, 2n minus 1 equals 25, what would you move first? The 1. We'll do the same thing here. We will add 1. Add 1. And now what do we do? Divide by 2. Divide by 2. So now we're to the part where we split it. Isolate the absolute value and then rewrite as your two equations. Okay, so when we rewrite it here, we're going to get, whoa, we're going to get an angry motor. Let me see if plugging it in makes it any happier. Okay, so this will give us 6x plus 5 equal to 13. And then 6x plus 5 equal to negative 13. And we solve those. So we'll subtract the 5. And we get 6x equals 8. So x equals 8 over 6. And this divides by 2, doesn't it? 2 goes into 8 4 times. 2 goes into 6, 3. 4/3 is the answer there. 4 over 3. This one is going to be prettier. We subtract the 5, and we get 6x equals negative 18, so x equals negative 3. So these are my two answers, 4/3 or negative 3. Now, number 10, it kind of looks like we can't do it right now because there's an absolute value and there's a negative. But this is not where I evaluate it. I isolate the absolute value before I decide whether or not I can do it. So I've got to add the 4. So now I have the absolute value of x plus 3 equals 3. Now this is a possibility. I've got an absolute value equal to a positive number. So we can split it to x plus 3 equals 3, or x plus 3 equals negative 3. So we subtract 3, and we get x equals 0, or we subtract 3, and we get negative 6. All right, on number 11, to isolate it on number 11, what do we have to do? Divide by what? Negative 6. When I divide by negative 6, I am left with 10 minus 2x, the absolute value of that, is equal to negative 4. Do I need to do any work? No. This is not a possibility. There is no solution. There is no way to make an absolute value equal a negative number. Okay, so you can't decide that until you get to this step. Like this one, you see a negative, but don't get jumpy, because when I divide by negative 3, it's not negative anymore. So this one is possible, whereas this one wasn't. So where we evaluate is right here, after we've isolated our absolute value. That's the step in which you evaluate, is it possible? So this one is, so we can split it equal to positive 3 and equal to the negative 3. And then this one ends up being 0, because I get 4x equals 0. Well, x is 0. This one's going to be a fraction. Whoops. I get 4x equals negative 6. So when I divide, I get x equals negative 6/4, and 2 goes into both of those. So my answers are 0 or negative 3/2 because 2 goes into both of those. Yes?
Up on number 9, in the corner there, that says 18, but the other one says 8. Right there.
Okay, here we were doing a positive 13 minus 5, so that's a positive 8. This, it's running into the blue, so it's hard to tell. It's a negative 13, take away 5 more, which is a negative 18. Yes, sir?
Are we not doing number 8?
We can.
Okay.
Sure. We'll do number 8. So here we add 1 and we get 5x equals 10. So x is 2. Here we add 1 and we get 5x equals negative 8. So x is negative 8/5. That one does not simplify, so we just leave it as an improper fraction. Okay, so that's equalities, equations. So in absolute value, how many answers do equations have? Normally, 2. It is possible for them to only have 1. Can you think of if the absolute value equals 0? So if I gave you something like the absolute value of 2x minus 1, equals 0. Well, positive 0 and negative 0 are the same thing, right? So this is the only case where we truly just have one equation to solve. Okay? And so we get 2x equals 1, x equals 1/2. So the only time we'll have an absolute value equation that just has one answer is when the absolute value equals 0. It's possible to equal 0. Is it possible for it to equal a negative? No. There's no solutions when we have an absolute value equation equal to a negative. Yes, sir?
1/2 squared, or you just leave it 1/2?
You would just leave it 1/2. If we plugged in the 1/2, half of 2 is 1, and 1 minus 1 is 0.
I didn't know if we would.
Okay? All right. Let's go ahead and flip to the back then, and we'll take a look at inequalities. Okay, today I'm going to show you one way to write an answer for inequalities. One way. We're just going to use inequalities. Tomorrow we're going to use intervals and number lines, because those are the 3 ways you could see it on the SAT and ACT. So we're going to start with inequalities, and then we'll add intervals and number lines tomorrow. And I'm not sure if your teacher is teaching you all 3 today in class, but if they are, know that in here we'll address the other 2 tomorrow. I know that I am only teaching one way today in class, and then tomorrow I'm going to add the other 2. Okay, the steps for this are very similar. The first thing we have to do is isolate the absolute value, which it's isolated on the first several. And then the second thing we do is we split it into 2 inequalities. So just like with equalities, we split it into 2 equations. Here we split it into 2 inequalities. So for the first one, it's already isolated, so then we can go ahead and split it. So the first one stays exactly the same. Okay? The second one what's in here doesn't change, but we switch the inequality, so it goes from greater than to less than, and then we change the sign. So this is a positive 5, it becomes a negative 5. Okay, so that's how we set it up. I actually probably should go back a step. Before we solve inequalities, we should also make sure it makes sense. Is there a way for an absolute value to be greater than 5? Yes. What if I got something like, is there a way for an absolute value to be less than negative 5? No. So we do need to still ask ourselves those questions as, is it possible, before we start solving. This one is possible, so let's solve it. Oh, we're done. There's nothing to move around. We're done. So, all of our answers either have to be greater than 5 or less than negative 5. Greater than 5 or less than negative 5. And I have to use the word or because it isn't possible for a number to be greater than 5 and less than negative 5. No, that's not possible. So this is definitely an or situation. And we're going to notice that every time we have greater than or equal to, it gives us an or situation. Greater than or equal to gives us an or. Okay, let's look at 14. So the absolute value is already isolated. The first one stays the same, completely the same. All we do is drop the absolute value bars. The second one, the sign switches, so it's going to go from less than to greater than, and from positive 6.5 to negative 6.5. Now, this is an and situation. Less than and. Less than gives us an and situation. So, all of our answers are less than 6.5 and greater than negative 6.5. Do you know when we have an and, we could write it as a compound inequality? Where you put the lower end down here and the upper end up here. Have you guys ever seen compound inequalities? Yeah. No? Okay. So whenever we have an and, we could write it as a, and the only time we end up with an and is when we start out with a less than.
What about less than equal to?
Or less than or equal to. Okay, so this is a less than. So will it be an and or an or? And. This is a less than. And or? And. Okay, so on this one, first one stays exactly the same. Second one, we switch the inequality and the sign. So here when I solve, I get x is less than or equal to 7. Here when I solve, I get x is greater than or equal to 5. So my answers are less than 7 and greater than 5. So if I write it as a compound, the smallest one to the biggest one. All my answers are between 5 and 7.
When you write it like that, to the signs always have to point towards the first number.
Correct. Yeah, you always, when you go least to greatest like I did, least over to the greatest, we have to use less than symbols. Yes, less than for least to greatest. All right, now this one. The first one completely stays the same. The second one switches, changes signs. Switch the inequality, change the sign. So we get negative x is less than negative 8. Okay, here's our last little weird rule that happens with inequalities. When you're solving an inequality, if you have to multiply or divide by a negative, what happens to the direction of your inequality? It flips, it switches. So to solve this, guys, I have to divide by a negative 1. So whenever you multiply, if you have to multiply or divide by a negative, then you flip your inequality. And we have to on this one. To solve it, we have to divide by a negative 1, so it flips from less than to greater than. Okay? And then the same thing's going to happen with this one, because we still have that negative x. But when we divide by negative 1, this one flips from greater than to less than. And this makes sense, because to be an and problem, are there numbers that are greater than 8 and less than 12? Yeah. So to write it as a compound inequality, the least one to the greatest one. Least to greatest.
You have to write it like that.
I do want you to get used to that. And it's not really for the test we're giving you. Like, I would give credit for this on my test. But I don't want you to miss this on the ACT, SAT. All right. Okay, so this is a greater than problem to start with. If it's greater than, then it's a or. Now, I'm looking at this one thinking it's a less than, but is the absolute value isolated? No. If I divide by the 3, now it's isolated, and so now I can decide. It's a less than, so this one is an and. Okay, I want you to try solving these two. The ors we can't write as a compound. The only ones we can write as a compound are the ands. So let me know if you have questions. The answers to these will be on our notes for today.